Hi everyone, welcome back to this series of videos on measurements. This is video number 10, the volume of a pyramid. So here we go. Suppose I gave you the base area, capital A, which I've colored in purple, and from every point on the exterior of that shape, I drew a line to a common point at the top, making a pyramid with a height h above the base. Then the volume of this pyramid would be 1/3 times the area times the height. So if you forget, we use A times h for a prism and 1/3 times A times h for a pyramid. If you're interested in why it's 1/3, I invite you to go online and have a look. It's not super straightforward. So for year 10 purposes, it's sufficient just to memorize this formula and use it to do calculations. But if you are curious, as I am, I encourage you to go and have a look and see why it's 1/3. And I think the amazing thing is it works for any shape, not just a square, not just a triangle, but it can truly be any shape. But we'll just focus on the simplest cases for our work. So let's start with a rectangular pyramid. So I'll need to draw one. And let's imagine the dimensions of the rectangle are 10 meters by 8 meters. And the vertical height is given by 12 meters. The result that we just stated on the previous slide was that the volume of a pyramid was 1/3 times the area times the height, where area refers to the area of the base, which is on the bottom here. The area of the base is the area of a rectangle with dimensions 10 by 8. So I can replace A with 10 by 8, and I can replace the height h with the number 12. And so you can see this is going to result in a fairly large calculation. But one thing I'm seeing is that 8 times 12 is 96, and 96 divided by 3 is 32. So this actually gives me the number 320. And since I'm dealing with volume, it's meters cubed. Notice how much simpler this was than the surface area calculation we did for a rectangular pyramid. So just like with prisms, in general, calculating volume is much simpler than calculating surface area. Let's do one more example. So here what I'm going to do is define a pyramid with a triangular base, and I'm going to make the base an equilateral triangle. If you've forgotten what equilateral means, this means all sides have the same length. And so that means I can draw these tick marks on the pyramid, or the base, I should say. And then we're saying the pyramid looks something like this. So I'll do the back with a dotted line. And let's say the side length of each part of the equilateral triangle is 9 meters. And the height of the pyramid, let's say that's 12 meters. And now we have a problem because we don't have a simple formula for the area of the triangle here. Normally we would use area equals half times base times height, but I don't have the height. What I have is this. The height, so just now I'm talking about the height of the triangle, not the height of the pyramid. Just be careful here. So if you're ever unsure, just be really specific about which height you're talking about. The height h of the triangle is unknown. But we can calculate it using Pythagoras' theorem. So just like we did with an isosceles triangle, I'm going to break this triangle into two. So I'm just going to consider one side now. So half of 9 is 4.5. And now I can use Pythagoras' theorem to get h. So 4.5 squared plus h squared equals 9 squared. And if I take away 20.25 from both sides, I get 60.75. And now I need to take the square root of this. And for the square root, you generally need a calculator. So here I get 7.79. Or we can just keep the square root and round at the end. It actually doesn't matter. I'll just keep one more decimal place. Okay, we've got the height. So now we can write the following. The volume of the pyramid is equal to the area of the base times the height of the pyramid. I've used h with a subscript for the pyramid here to distinguish it from the height of the triangle. As long as you are clear in your calculation by showing me which numbers you are substituting, you'll get full marks. So the area of the triangle is given by half times the base, which is 9, times the height, which is 7.794. And then I want to multiply the whole thing times the height of the pyramid, which in this case is 12. So let's go ahead and do that. I'll write 0.5 times 9 times my answer to my previous calculation. So you'll see I've written A and S there. You can also do that on a scientific calculator. Times 12. Okay, and we get some number. 420.89 cubic meters, because I'm dealing with meters and I'm dealing with volume. And this is rounded to 2 decimal places. Okay, so that's the volume of a pyramid. It's easy to get lost in the details because we started off with a volume calculation and then we went into a Pythagoras calculation to get an unknown height. But the basic idea is if you have a pyramid with a base area of capital A and a height h, all you have to do is 1/3 times A times h to get the volume of the pyramid. And I've just noticed I've made a mistake because I need to do 1/3 times A times h. So hopefully you picked that up as you are watching this video. So I can take the answer to my previous calculation and divide it by 3. And that gives me 140.30. Okay, I make mistakes too. So 1/3 is the factor you need out the front for finding the volume of a pyramid. I'll even write a note here. Don't forget this. Okay. Thanks everyone. I'll see you in the next video.